Hello everyone, welcome back to the channel. I hope you all guys are doing really amazing. Let's see today's weekly contest solution. Okay, so I will post the solution to all the four problems, and you can skip to the problem whichever you could not do, or you can listen to all of them also. So let's see the first problem. It was a very simple one, you can say. You are given a sorted integer array nums and an integer k. So you need to return an array such that each distinct element appear at most k times while preserving the relative order of the element. Okay. So if you look at this array, 1 is present 3 times, 2 is present 2 times, and 3 is present 1 time, and k equals to 2. It means that each element is eligible to be present at most 2 times. Okay. So one can be present at most 2 times. It is present 3 times, so only 2 times you need to output this in your answer. And for 2, you see it's already present 2 times, so you do not need to remove anything. For 3, it's present just a single number of times, so you do not need to do anything for that also. So yeah, uh, only the cases which violate this k equals to 2. So you see 1 occurs 3 times, but k is 2, so you need to reduce that to 2. Only this thing you need to do. Okay, so approach is pretty simple. You can just have your final vector and a map which will tell you what is the frequency of the current element. So if you see the frequency of the current elements is already 2, okay, it's already at the maximum. This is the maximum frequency which can occur, right? So if that number frequency is already the maximum, you can just continue. Okay, you do not need to do anything. Otherwise, you increment the count in your map and you also push back that element. So for the first one, it will, when it will encounter, it will see that map of 1 is 0. So it will increment map of 1 as 1, and it will push back 1 as your answer. Okay. Then as for the second time, it will again do the same thing, and map of 1 will be 2. Okay. Then when it encounters the third one, it will see that the map of 1, it is already 2. So you cannot increment anything. So you just continue with it. You cannot push back anything more in your answer. So in this way, the third one will be skipped, and the other values will simply be added. Okay, so yeah, you can do this. I guess it was pretty simple only. Let's move on to the next question. Yeah, those will take much time to discuss, but yeah, I guess this one was also pretty simple only. So all you need to do is just brute force. Okay, so you are given a string password. The strength of the password is calculated based on the following rules: 1 point for each distinct lowercase, 2 points for distinct uppercase, 3 points for each distinct digit, and 5 points for any of these characters. And apart from all these things, any other character will not be present in the string. It is already told in this. Okay, so password consists of lowercase, uppercase, digits, and special characters from this only and nothing else. So you do not need to be worried about any edge cases also. So just one thing you need to see, that if b is present 2 times, you need to only increment 1 time. Okay, so you see, for the first b you just increment, and for the second small v you do not do anything. So only the unique values you will take. Only the unique values you will take. So one thing you can do is that prepare a set of characters. Okay, so for all the elements in the password, you can insert one by one into the set. That will ensure that you have only unique elements present. And while iterating through the elements, you can just check whether they lie from the smaller case of a to z. Then you add 1 to your answer. If they lie from the upper case of a to z, you can add 2 your answer. And for the others, you can just do whatever it is told. Right, 3 points for distinct digits and 5 points for the distinct special characters. Else return the answer. And that's all. I guess the second problem was also really easy. Okay, yeah, from the third problem, things will get a little bit interesting. So let's see. Yeah, coding wise it is not difficult, but uh, intuition wise you can say that this is a medium difficult kind of problem, and the jump from problem 2 to problem 3 is good in this contest. Okay, so let's see this question. And you are given an integer array nums of length n, where nums is a permutation of the numbers in the range 0 to n minus 1. So nums will contain distinct digits from 0 to n minus 1 only. It may be present in any order. Okay, so you can perform the following operations. one thing you can do is reverse the entire array, and another thing you can do is rotate the left by 1. Okay, so this means that rotate left by 1, it means that move the first element to the end of the array and shift all the elements to the left by 1 position. Okay, so it simply means that if you want to rotate an array, so let's say you have an array which is something like this, and if you want to rotate it to the left, it means that first element will go to the last and all the elements will get shifted by one position. So that only means this. Okay, you may perform this operation or you may reverse the array also. Return the minimum number of operations required to sort the array in increasing order. If it is not possible to sort the array, return -1. So as you can see in this array, only whatever array will be given to you. Okay, whatever array will be given to you, only 0 to n-1 will only be present. So if it's an array of length 6, only 0 to 5 will be present in some random order. Maybe 5 is present first, then 0, then let's say 1, then let's say 4, then 3, then 2, something like this. Okay, so any permutation, this means permutation, right? So for an array of length n, 0 to n-1 will only be present in this array. Okay, so that thing is done, and you see for this number, for this nums, what you do, you output 2. Okay, so what do you need to do in your final? You need to, let's say if you are given this array, if you need to rearrange this into something like this. Okay, you need to rearrange this into something like this. Now if you notice, you need to shift the relative elements of the array. Okay, you can only reverse it or you can shift. Okay, you cannot swap some elements, so you cannot just say that I will swap 1 and 4. That cannot happen. So this also shows that not always it will be possible to sort. So for this example, if you see 2013, no matter how many reversal you do or how many shifting you do, you cannot sort this array by 0 1 2 3. So that's why the output will be -1. Okay, so otherwise you need to tell what is the minimum number of operations you need to sort the array. Okay, so one thing, there are many observations in this problem, so we will try to note them one by one. Okay, so let's say you are having an array, you need to make a particular array into something like this. You are having a 6 length array. This is your final target which you want to change to. Okay, for that you can do either left shift, as I told, or you can reverse. Two types of things you can do. These two operations you are allowed to do. Okay, so one thing you see, what if the array is present something like this? Let's say 2 3 4 5, and let's say it's present to be 0 1. Okay, the array is present something like this. Then you see that this array is actually a cyclic in nature. That is, if you write the array 2 times side by side, okay, then you will get what you want to achieve. That is, you want to achieve this 0 1 2 3 4 5. You see, for this part, it is just 0 1 2 3 4 5. So this array should be cyclic in nature in order to form it, or it should be reverse also. It can be reverse also. So one thing is that it can be initially if you try to see, uh, if you let's say this array, if you want to convert it to this array, what are all the things which you can do? Okay, so you can tell me that, hey, I can shift the 2, then I can shift the 3, then I can shift the 4, and I can shift the 5 at the end, and this way I will get all of them. Okay, but if you have an array something like this, uh, let's say 5 0 1 2 3, you can say that for this array it is very simple, right? Why it is simple? Because all you need to do is left shift 1 times, that is rotate left 1 time. So this array, this 5, if you just shift to the back, you will directly get the array which you are trying to find. Okay, but now comes the interesting case. Okay, so let's say if you have something like this, 5 4 3 2 1, and let's say 0 is present something, not this. Okay, I'm just forming the array. So After 0, there is 5, 4, 3, 2, 1. So let's say this array is given in your question. Okay. Now, first of all, you can check whether you are able to form this array or not. Okay. So form the final array, which is 1, 2, 3, 4, 5, 0, 1, 2, 3, 4. You want to change this to this. Okay. So one thing, if you see, if you shift it, if you rotate left one time, what will you get? If you rotate left one time, what will you get? You will get 5, 4, 3, 2, 1, 0. Okay. Then again you try to rotate left another time. So what will you get? 4, 3, 2, 1, 0, 5. Okay. Then again you try to rotate left another time. And you go on. Nowhere you will get this 1, 2, 3, 4. Why? Why does this happen? Because you are only using the rotation operation and you are not using any reverse. So you see, at this position, after the first rotation, okay, if you were able to reverse this array, then only you can get. So reverse operation become mandatory in such a case. Okay, reverse operation becomes mandatory in such a case. So if the cyclicity of the elements, okay, is present in a descending order, so I am telling you a statement. Tell me if it is, you can understand this observation or not. If the cyclicity of the numbers is in decreasing order, that is the number which you are, the array which you are given, let's say this array is also, let's say, generated from one more array, which looks something like this: 1 0 5 4 3 2. Okay, then if you rotate this array to the left, you will get this, and then again you rotate it, and then you reverse it, and then you will get the answer, right? So the thing is that the cyclicity of the element, by that I mean that uh, if you try to find these elements traveling from left to right, you find most of them to be in the decreasing order or not? Okay, so if the cyclicity of the elements, by cyclicity I also mean like this, that if you write these arrays side by side, so let's say this array, if you consider, okay, this array, and if you try to write this 0 1 5 4 3 2, 0 1 5 4 3 2, so you write two times this array side by side, and you see that you get the reverse array also. You get this reverse array. You get this reverse array. So I tell that the cyclicity of this array is in decreasing order. In my earlier example, which I was seeing, okay, in my earlier example, which I was seeing, if you write these elements side by side, 5 0 1 2 3 4, and again, not this one, right? Hmm, which example I was showing you? Exactly this one, right? Let's say you have this array 5 0 1 2 3 4, and if you write again this element 5, means side by side if you write it, okay, so 5 0 1 2 3 4, again if you write it, you see you get this part of the array. So not this part, sorry, you get this whole part of the array 0 to 5. And in this case, if you are writing it side by side, the cyclicity is decreasing order. Okay, 5 to 0 you get, but here you get 0 to 5. That is, I tell that the cyclicity is increasing order. Okay, so my observation was that if if the cyclicity of the numbers in in the array is decreasing, then one reverse is necessary. One reverse is necessary. Otherwise, you cannot sort it ever. That is one reverse or odd number of reverses. And if the cyclicity of the numbers is increasing, that is, if you write the array side by side, and if you get an increasing array from 0 to n minus 1, then uh, you may not reverse, you may not reverse, may not reverse, or you can do one thing: reverse twice or even number of times, or reverse even number of times. Then you will say that, hey, why will I reverse even number of times? Because If I reverse an array 2 times, it becomes the same array. Then there is the question. Okay, so let's try to do something. Let's try to see one another observation. You have, let's say, 1 0 2 5. You have this. Okay, you try to reverse this first. Okay, first reverse this 5 4 3 2 1 0. Okay, then you try to cyclic shift this right. Okay, one operation you used reversal, another operation you are using is uh, left rotate. Okay, so what will you get? 4 3 2 1 0 and 5. Okay, so now you again reverse it, because see what I want 2 times reversal. Okay, so I'm just trying to see various permutations to see what can 2 times reversal give me. So if you see 5 0 1 2 3 4. Okay, so you try to see how has this array changed over time. How has this array changed from the first to the last? You will say that, hey, our left rotation was possible, but if you see here, this is nothing but right rotation, which was not given in the question, but I have figured out a way by I can do the right rotation. Okay, right rotation. So you can say that one right rotation, only the left rotation was allowed as an operation, but I have found that right rotation is equals to reversing the array plus left rotation plus again reversing the array will give you one right rotation. Okay, so this observation is important. What if I want to rotate it right 2 times? Okay, what if I want to rotate my array right 2 times? Then instead of here doing left 1 time, I will do 2 times left. So basically, if I want to rotate my array right n number of times, okay, so n times, if I want to rotate my array right, then what will I do? I will reverse the array, then left. I will do this n times. Then again reverse my array. Reverse at the first and reverse at the last. Okay, so plus 2 number of operations I need extra. Now you will say that, hey, you are telling all this, when do we exactly require this? When do we require a right rotation? Okay, so let's say we want to reach to the array which is something like this: 0 1 2 3 4 5. Okay, and you are allowed to do left rotation only. So let's say you are in the question, you are given this array. Okay, and if you see this array, if you then again at first you will write it side by side and tell me that this is an increasing number of arrays, so I may not do the reversal operation at all. Okay, or I can do the even number of times. Okay, so but one thing, if you notice in this question, is that if you try to do only the shifting, first you do the left shift, what you will get? 2 3 4 5 0 1. Then again you will shift once to the left, 2 to the left. Okay, then you will get 3 4 5 0 1 2. And again you will shift. After many operations you will reach 0 1 2 3 4. Okay, so you require a lot of operations for this. Instead, what I can do, I can do one right shift. Instead of doing all of these, I can do one right shift. Right shift. What does right shift mean? 0 will move to right. It means that it will move to the front. Instead of the left rotation, I will rotate it like right. You see, you directly get your answer. So in such a case where you need a right rotation, maybe by doing some right rotation, you will get your array. So reverse it, then left rotate it and reverse it. Okay, reverse it, left rotate it and reverse it. So this is the idea. This is the whole idea. So what do I do? At first, I get the array, right? I get the array. I find the position of the zero. Why do I find the position of the zero? See, 0 need to be present at the first, right? So let's say 0 is present in the ith position. I know that I need to shift my 0 I number of times. Okay, and the array must be cyclic. That is, if you write the array side by side 2 times, you must get the array which you want to do. Okay, from 0 to n minus 1. This array you should get, or the reverse array you should get if you write it side by side. Okay, so I find the position of the 0. I try to find the position in which the 0 is present. Okay, and then I will try to check whether the next element should be 1, next element should be 2, next element should be 3, and so on. Okay, or I will also check that whether this element should be 5, this element should be 4. Okay, or if it is present in the reverse manner, I will check that whether the last element should be, the before element should be 1 or 2 or 3. Okay, this way I would like to check whether it is increasing or it is decreasing. So that's why I took out the position of the 0. So I iterate to the nums. If nums is 0, I take out the position of the 0th element. Okay, now increasing is true and decreasing is true. At first I write this. Okay, now whether my array is increasing or decreasing cyclicity, that I need to check. So you see, nums of position plus I should be always I. What do I want to say? Okay, now you see, this is the index position now, right? If you do position plus I, you will must get that always I. Okay, so if you do, let's say, jump 2 steps, that is you do position plus 2, you should get 2. If you do position plus 3, you should get 3. Okay, if you are not getting, it means that it is not arranged in increasing order. Okay, and if you go to the last element, you will add up the position to overflow the value of n. That is when you do the modulo, because n modulo n will be 0 and it will help you to go to the first index. I hope that much you can understand easily. And that's why if nums position plus I modulo n is not equals to I, okay, then increasing equal to false, because always it should be equal to I, then only this true case should be valid. Okay, otherwise you take it to be false. Now the nums also, for you check whether it is an increasing array or not. That is for the forward positions you check. Now it might be possible that this is 0 and this is 1, this is 2, this is 3. Then you try to check from the position, you subtract I this time. This time you subtract I. Okay, and for subtraction, you know how do we do the subtraction in modulo. So if you want to find a plus b whole modulo, I hope you know this already, but still I'm telling you, you do a modulo b, a modulo mod plus b modulo mod. Okay, you do it like this. Okay, but if you have a minus b modulo, if you want to perform this operation, this can also be a negative value. Okay, so how will you do the modulo negative? So in this case, it is often feasible to calculate this particular thing, plus mod whole mod. Okay, this ensures that it always stays in the positive range. Okay, it always stays in the positive range of real numbers or integers, and you obtain valid modulo. So if you are doing modulo n over here, then you do position minus I plus n modulo n is not equal to I. Okay, then decrement is also false. Okay, now you know whether your array is decrementing cyclicity or incrementing cyclicity. Okay, you know out of these two things. Now if your array is increasing, okay, what do you do? What can you do? There are two choices which you can do. One thing is that you can shift to the right, shift to the left. Okay, in that case, if let's say only shifting to the left is happening and it's correct. Okay. So let's say as I told you, if this is a position, this 0 is present as position index and you want to bring that to the 0th index, then you need to shift this position number of times. Okay, so they need to shift this position number of times. So I need to find the minimum. So minimum of answer comma position or n minus position plus 2. Why is this? Okay, now if you see, if you are telling that an array has 0 present at the last, okay, I told you how to do the right shift. Now the right shift, as I told you, is nothing but many left shift plus reverse. Okay, many left shift. So right shift is nothing but many left shift plus reverse at the beginning, reverse at the end. Okay, reverse at the end. Okay, so this means that 2 times extra operations you are doing. So if you, let's say, if you shift position number of times, if you shift position number of times, you can reach your 0 to the front. Also, you can shift n minus position number of times to reach your arrow 0 to the end of the array. Okay, to the end of the array. But for that, for this right shift, which is not allowed in our operation, you need 2 more reversals, because reverse left 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 and then only reverse you can do. So this accounts n minus pause plus 2 accounts for the right shift. Okay, so here you can say like it is, you have two choices. Okay, first is left shift only, left shift only. Okay, second choices is reverse plus left plus reverse, some n times left. Okay, some x times left. Okay, x times left plus reverse. This includes this uh, tells that right shift only, right shift only. Okay, this is nothing but right shift only, x times, obviously x times. Okay, so that's the two choices which you have in increasing. And for the decreasing case, if you see our observations, what we had written, if the cyclicity of the numbers uh, is increasing, you may okay, you may not reverse. Okay, but if the cyclicity of the array is in decreasing, one reversal is necessary. Okay, so first you can reverse and then uh, shift left, or you can first shift left and then reverse. You can do both of them. Okay, so this accounts for this only, that this in this, what you are doing, you are reversing at the end and shifting first. Okay, so position means you need to shift your array this many number of times plus modulo n and plus 1. Okay, because you are reversing it, and if you are first reversing and then shifting, then it's simply n minus pos. If you just take one simple example, so far as I have shown you, I guess this will be very simple. Okay, not at all difficult to understand. So yeah, after doing all this, if you happen to get like both increment and decrement to be false, then it will not enter any of these loops, and answer will be 1e9 as it is. Answer will be 1e9 as it is. That's why you return -1 over here and return. Otherwise, you simply return an answer. So yeah, I hope this problem was very clear to you. Okay, this is a little bit tricky. You see, the acceptance rate is also just 20%. It means that it's very easy to make a mistake in this problem. So let's go to the next problem. I hope this is very clear to you. And yeah, this problem is a good one. An interesting technique is there. So number of pairs after increment. Okay, so you are given two integer arrays, nums1 and nums2, and 2D integer queries. So you will be given queries. Queries are of two types. The first type of query is that from range x to y, both inclusive range. Okay, both of the inclusive range, you need to add val to your answer. So this is like a range update you are doing. Okay, every time you are doing a range update from x to y, both inclusive. Okay, and 2 total means that compute the total number of pairs j comma k such that nums of 1j plus nums of 2k is equals to total. Return an integer array answer where answer j is the total number of pairs for the jth type of query too. So if you try to notice, this nums1 is the only a 5 length. Nums2 is 1e4, 5e4. Query is 5e4. Okay, so you cannot do query into this you cannot do. Okay, so in every time in the query, you cannot just iterate through the array and check the frequency of all the numbers and then tell that the number of pairs where nums of 1 of j plus nums 2 of k is equals to root. So you cannot do this. But one thing you can obviously do is that since this is a very small array, this is only a 5 length array or a very small array. Okay, you can take every possible pair of j and try to calculate k in a very small number of time. Okay, so what I want to say is that you have one array which is small, nums1. Okay, then tell that you have this array nums1 which is small, very small, and this array is big, nums2. This array is big too. This array is very big. And you want to take a j index from here, and you want to take a k index from here. Okay. And you want to check for this whether this is equals to the total value. Okay. The query of the type 1 is there, query of the type 2 is there. 2 will be given total. And here xy or L to R range. From L to R range, you need to add the value val to all of them. Okay. So these are the two types of queries which you need to perform on your array. So first of all, try to think of the brute force and think that what will be the issue if you start with the brute force. So first of all, what do you need? You need nums1, okay, nums1 of ij plus nums2 of k equal to total. This is you need, okay, for this particular array. This means that you need to find whether a k is present such that nums2 of k is equal to total minus nums1 of j. Now you can iterate through all this j. Okay, you just need to iterate through all this j and check whether any such k nums k exist. Okay, now if you think of a brute force solution, what you can do, every time you have the array with you, nums2 array, every time whenever you are asked to do a range update, what you do, you update this whole range. So you add the value val plus val plus val plus val to all of them. To all of them you add the value plus val. Okay, and once you have this changed array with you, you also store them in a map. Okay, so map of integer comma integer, let's say if you keep it, and you, this will, what will happen with this, you will have the element comma frequency for all of them, and you just need to check, that whether in this map, this nums1 total minus nums1 exist or not. Okay, total minus num1 exist or not, and if exists, how many times does it exist. So this will, so answer plus equals to this. You can see you need to find the number of pairs j comma k, right? So for all the j, because j is very small, j is, for all j, even if you iterate, it will be only 5 length as it is told in the question. Nums1 is length 5, so you can iterate for all the j. You can do this, answer plus equals to map of total minus nums1 of j. Okay, but if you see again, if you try to create the map and if you do the range update every time, it will be very hectic. Okay, so this is the question where we need to look at the constraint. The constraint, if you see, it's 5e4, not 5e5 or 1e5. It means that, so 1e5 or 5e5, it means that if it was 1e5, not only O of n, and O of n log n solution will also be valid. But these types of question, when 1e4 is there or 5e4 is there, here O of n root n solution is also correct. Okay, not only n log n root n solution is also correct. So this gives you a hint, and it is actually a standard method where you have a long array of length n. Okay, and if you try to divide those array into blocks, okay, you try to divide those array into root n number of blocks. Okay, this will be block 1, this will be block 2, this will be block 4, and so on. Maybe the last block is a little bit small, it may be possible, but if you iterate through the blocks, it will take you only root n number of times. If you iterate through one particular block, again it takes you only root n number of times. And what if you want to update? Let's say you divide it into blocks, and let's say from this number till this number you need to update. Okay, so I will show you how updation you can do very easily. So let's say you have divided your whole array into blocks. This is a block, this is a block, this is a block, this is a block, this is a block. Okay, and you are asking, question has asked you to do a range update starting from this value L to some value here R. Okay, so what you will do in that case, you will have a blocks array also, which will like block 1, block 2, everywhere it will store how much value we are adding. So if you are adding a value val to all of them, first what you will do, you find the start block, you go with L, and till the end of start block you add a value val to all of the elements which are present. Okay, then let's say this is the block 1, this is block 2, this is block 3, then you go iterate through block wise. Okay, you do block 3 and plus equals to val. So this will mean that every element is added val number of times, but although it is not actually added in the array, but you can store it like that. Okay, block 3 also, here see, you can iterate through the blocks also. Block 3 will be plus equals to val. I hope you are understanding, okay, not getting confused. And once you reach the last block, from the starting of the last block to the ending, that is to R only, you can add a plus val to all of the element which are present. Okay. And I told you about map, right? In a vector, like you can check total minus nums of 1 of j, whether this is present in the map. In this, you take a vector of maps. Okay, you create a vector of maps, and each map will tell you the status of the frequency of each element in the block. And if you want to get the frequency of a particular element x, you can simply iterate through all these vector of maps and add all the frequencies of this particular value x, where x is, let's say, total minus n1 of t. This is what you can do. So yeah, I can directly show you the code. I hope this will be simple to understand only, not at all difficult. So at first I have this nums2.size, then I go take the size of each block. So as I told you, the size of each blocks will be square root of n plus 1 I take for safety. Okay, because the square root of n will truncate some values also. Okay, so I don't want that to happen. So for just for safety, I can take one extra only. That will not affect in my time complexity, because O of root n plus 1, that won't affect much. Okay, now you see the number of blocks. I hope this is simple algebra, you can understand. If the blocks is square root of n plus 1, then the number of blocks will be n plus block size minus 1 by block size. Okay, this is the number of blocks. Okay, count of the number of blocks. Now, as I told you, I will keep some vector of maps. Okay, these vector of maps I keep. So this, I will call this vector of unordered map I keep, because it has an amortized O of 1 time complexity. That's why we should always use an unordered map in most of the problems. So vector of unordered map, long comma long I do. Okay, and I initialize it to the number of blocks. Number of maps will be equal to the number of blocks only, because each map will store the frequency of all the elements present in one particular block. Okay. Now this is the additions. What is the additions? Uh, this blocks, whatever I was telling you, this is basically the additions. If you do if you know the lazy propagation of the segment tree, this is also something very similar what you do. Every block, you just see that how many additions have happened here. Okay. At first, you just iterate through the blocks, iterate through all the numbers in nums2. Okay. So you are iterating through the nums2 and just storing every element in nums2 just by the block number. So this I by block size gives you the block number. Okay. So in block number 0, this element is present and its frequency is increased. In block number 1 or 1, whatever block number will come, that particular element is present in that block and its frequency is increased. In this way, you can store all the frequencies. Okay. Now it's time for the queries. Okay. So when you get the queries of type 1, what do you do? From L to R, you need to do a range update. Now, just as I told you, how do you do the range update? Just like this. Okay. From starting from L to the end of start. Okay. So you need to iterate and store a plus value for all of this. So first thing you see, if start B equals to C, this is the starting block number. L by block size, it means that from L to R you are iterating. So this L lies in the starting block number, this L by block size. This R lies in the ending block number, R by block size. Okay. Now, if the starting block is equal to the ending block, what does this mean? This simply means, just a second. Yeah. So if the starting block and the ending block are the same place, both L and R lies in the same block, then you just need to iterate through this particular block. No haphazard way of doing that. Okay. So you just iterate through L to R, and this will be order of root n only, because you are within a single block. This will be order of root n. What do you do here? You do the blocks of start B nums2. So you this is the map, right? Blocks of this is nothing but the map where frequency you are trying to store. So you decrease the frequency of the already existing element, increment its value by val, right? whatever value you need to increment, then incremented value you just store in the block. So earlier, let's say if you are adding a value to, let's say, to 5, earlier map of 5 was present. Okay, let's say some number map of 5 was present. What do? You do map of 5 minus minus, remove 5, then you add 5 to 2, you get 7, then you do map of 7 plus plus. This is what essentially you're doing, removing one element from the map, then again incrementing this v, and then again adding that element. Now what if this start and end are not in the same block? Then you follow the same thing. Okay, follow this thing, start from L and go to the end of start. Okay, so from L, what is this I have written? To try to see, this is nothing but you can tell it is LL end of start, something like this. What is this? This is start blocks plus 1 into block size. This will give you the element ending of the first block. End of start. Instead of end of start, I mean to say that it is the end of the starting block. Okay, so start plus 1 into the block size. This is what. Okay. And you do the same thing over here with nums2. You decrement that, increment that value by v, and then again. This is the first block. You have finished processing till here. So basically, this part of the processing is done. Now we will process all the middle blocks. How we will process that? You just iterate through the blocks. Additions you do plus equals to v. This additions of I tells you that in block number I, all the values are added by this. This is nothing but that. Okay, and now you have also processed this one. Now the last one you need to process, and that is very simple. Just do end b into block size. Start with this end block start. Okay, end block start, and this is till r you will go, right? Till r you will go. Here is the r, so till inclusive range of r you will go. So that's why less than equal to r, and you do the same thing over here. And in this way, you have done the range update in very optimized way in O of root n only. Now, what if you have the query of the other type? It is not of the type 1. Then it is very simple. You see, as I told you, nums1 is a very small array. You can always iterate through that. That is a constant time only you will iterate, because this is 5 only. And for every x in nums1, what is your total requirement? This is the value total. This total minus x, this is your requirement, right? But now you see, now check the frequency of every block. So let's say if you want to see the number which you are searching for, right? Let's say total minus whatever that number is, nums of 1 of j. This number, let's say x, you're searching for this number. This may be present in any of the block, right? So you see how many times is present in block 1, how many times is present in block 2, how many times is present in block 3, and so on. Add the total number of times. That's what only you need to do. So just count 0. This is your requirement. You need to iterate through the blocks. Okay, now the additions also you need to subtract. This is not your actual requirement, because the additions you did not do when, see, for the middle elements you did not do the actual additions to the array. You just stored it in some additions array, so you need to subtract those also. So additions why you subtract, and you just store whatever is the count of that elements, what is the count of that needed element present in block I, and you add through all the blocks. Add this through all the blocks. You have the total count, which you can finally push to your answer, and you can return answer. I hope you have understood the statement very clearly and understood the solution also, and definitely you should try the problem on your own first before listening to the solution always. So yeah, that's all for this video. Yeah, if you have any doubts still, you can definitely ask me in the comment section. So yeah, that was all for this contest. All the 4 problems, I hope is very much clear to you. So yeah, I will meet you in the next video. Till then, thanks a lot.